All right, welcome everybody to another edition of Cloud Experts Unleashed. I'm Ryan Brown, your host, and with me today is Justin Herron. He is a cloud architect with Tampa Devs. And xByte, we had the privilege of helping them out with a donation to help out their public cloud. So today we are going to talk more about that public cloud, kind of what it is, kind of we have a lot of tech people out there who listen, so the technology stack involved, that's important. And then a bonus piece, Justin was working for another company and took on a role as a cloud architect on this. And so we're gonna kind of touch on that for a second and what drove him, because I know a lot of you listening have passion projects and are thinking to yourself, should I stick with my company or kind of take on something I'm more passionate about? So we're gonna go through what Justin's thought process is on that. And why he loves this project. So, Justin, welcome. Thank you for joining us today.
Thanks, sir. Glad to be here.
All right. So, the Tampa Devs public cloud. Tampa Devs. We'll start there. What is Tampa Devs?
So, Tampa Devs really is it's a community of nerds. You know, I call it a community of keyboard slappers and web app crafters. You know, where it's people that are just kind of like, hey, look, I made this really cool thing. I'd like to show it to other people. And it gives you that ability to do that without like, all right, well, let me go over here and submit this proposal to this VP who has no idea what I'm actually writing about, but he's just like, does it give us a return on investment? When really the developers just want to be like, hey, I just made this cool thing. And I just want to show that. I don't want to do the whole business side of things. I really just want to show this cool thing that I made. And that's it. And it almost kind of speaks to like how I kind of see it. It's like back in the early days of the internet where like the 2005, I know it's not the early days, but like 2005-ish. You know, when you had nerds sitting around on their Windows little boxes, and they're just sitting around playing games with one another, and they're just playing on computers because it was fun. And that's kind of what I've been trying to like stay around with Tampa Devs. It's just like, hey guys, this isn't corporate. You're not showing up to a job here. Like you made a thing.
Yeah, let's just go off a cool thing.
Let's celebrate that.
Now, the public cloud then. What's this public cloud initiative and kind of what started this?
So it's actually kind of a funny story. So initially, I was working for a company and I was working with the networking team. Like my primary background is network operations. Like it's a weird obsession I have with packets, but I really enjoy, taking whole streams of traffic and just throwing it over here, and then it just keeps going that way. It's like, let me take this whole 40 gigabit stream real quick and just throw it over here. And it was always really, really fun because like there's a game I used to play a lot, which is called Factorio, and I always would be like, with a motto, like the predecessor, like the game after it's called Satisfactory, which is probably what everybody knows. But it's like the 2D version of that game. But the part that I was always really, really enjoying was like doing, because you have this game where you have like these miners and what have you. The miners sit there, they mine the minerals, and then you put them on the belts, and then they move them. I've always been really, really into just the belt part, like how to efficiently settle that up. And before I started IT, I got some really good advice by someone, which was no networking. I'm like, why? Because if you know the network, everything else falls into place. And
sure,
best advice I was ever given. And it wasn't by it was that old neckbeard guy. Every IT guy knows that.
The wise.
Yeah, Gandalf, the bearded guy sitting in the back over there who's just, he's got that dad vibe about him where he's just like, I don't care. I just want to do my job. but anyway, to get back on track here. So I had an old VP of mine reach out and say, "Hey, man." So, hey, he goes, "We're building a data center right now. We can use some help. And I know you want to get some BGP experience. You want to come over here?" And I was like, "Yeah." I didn't even ask him, like, "Hey, how much does it pay?" I didn't care. To me, what it was is that I got to go sit at the table with the people that build the internet. And to me, that was like, holy crap. It's just like, this is the opportunity here to like really catapult myself. So like, because I've always looked at the guys like Dennis Ritchie, Kevin Thompson, the guys who originally built Unix and the C language, and then, Brian Kernighan with his awk thing, like the guys of the 70s who started off with nothing and then they built everything. To me, that's just like, what? So, but when they reached out to me and they said, "Hey, we're building this whole data center out. We could use your help here, and this would be a great opportunity for you to get some co-location space, and you get to work on the data center side."
Oh.
So, but I need to backtrack a little bit here. But prior to that, when I worked at Hostway, the company where I met my VP at, I was like begging, like, "Please let me on the networking team," because I would walk in the data center and like they'd have to drag me out of there because it was just, there's just something about those rooms for me where it's just screaming metal, electricity, and plastic all coming together that creates these virtual worlds.
Yeah,
and
you love that networking.
Yeah. But what it was that like I was walking around the data center and there was this switch at the top of the rack. And this goes down a whole avenue, but basically the top of the rack switch was this thing called a Quanta T3048LY9, which was at the time an $8,000 switch. It's called a leaf switch. So in data center topology, we have what's called a spine leaf architecture, where we have our big beefy switches at the top that have our 100 gigabit. And then we have basically two legs that go down to child switches, and then those get MLAG together, and those are called the leaf switches. And at the top, the big beefy ones, we call those the spine switches. And then we originally called the class topology, or what is known today as the spine leaf architecture. But what's interesting though is the class topology actually dates back to the 1950s with what's called a crossbar switch, which was really cool when you look at it. It's this whole thing of like switching electric analog signals over this big square, and depending on how the cross sections are set up, you could send a signal all the way through the square. But that was back when, back in the early days. But that's an evolution off of that. Like a guy's named Charles Kloss patented it. And then the evolution of that really was the spine leaf architecture, the class topology. Well, I found, getting back to the switch, I saw this switch and I was like, I want one of those. But it was like $8,000. I'm like some L1 data center gangster just making like no money. And I was like, there's no way. So I was like, I got to figure out a way to strategically take equipment to an alternate location, AKA steal. But they were all like really guarded, and it was just like, so I went to my VP and I was like, "Can I just play with one, please?" And he's like, "Yeah, go get one. It's right over there." All right. I got to ask for approval and I can just take it. And he's like, "Yeah, take it." So I took it, and data center switches are in a class all by themselves. I learned the differences between what a white box switch was, what a bare metal switch was, and that's a whole topic for a different story. But when I was working at the job that I left that I left Hostway for, I got a job at Red Hat working on the networking team over there, and then I was still trying to get one of these switches. And anyway, there was this home lab little group we had inside of the BU that I was in, the business unit, and I reached out, I was like, hey, does anybody know where to get one of these switches at without paying $8,000 for it? I'm like, this is like a car. And one of the guys there pinged me. He's like, hey, I found this one here in Minnesota for $250. You want that one? I was like, yeah. So I reached out to the vendor who was selling it at the time, and he's like, yeah, it's just a bare metal switch. There's nothing on it. It's $250 plus shipping. Here you go. And I was like, take my money now. So they shipped it to me, and like literally, I met the UPS guy out there. I was like, gimme. So I reached out, I went over there and got that switch and brought it inside there. I was like, yeah, cool. And like, dude, I had a smile that was from here to here. And then I put it in my little homemade rack that I made out of 2x4s. Like 2x4s and pocket hole screws, and then like took the rails, and yeah, it was really jank, but it worked. And then anyway, like I brought that home, and when I brought that back into my office at my house, I brought it over there, I put it in place. I was like, yeah, you powered it on. I was like, all right, what do I do now? Oh yeah, Justin, you gotta learn how to use this. There's this thing, right? So all right, cool. So I started doing research, and when I say I started doing research, it was like, here's this grenade of knowledge, and then like, let's go ahead and down this path. And I learned about what's called ONI, Open Network, so it's called Open Network Install Environment, which is almost like Pixie for switches, but it's not. It's really it's different. And then like I learned about the network operating system in this whole new world, and found out like how Juniper and Cisco actually utilize it. They actually run BSD underneath the hood with a containerized, not sure if it's a virtual machine or container, but they run their application inside and then redirect all the VCY or the console access to the virtual machine. So you never really see the operating system, but it's this bare bone operating system underneath, but you're just interacting with their application. I was like, all right, cool,
And was this the starting point of the public cloud, or where did even the idea of having a public cloud within Tampa Devs, where did that come from?
Yeah, I'm sorry, I know I'm rambling right now, but let me jump to that. I went to an event at Tampa Devs, and it was just like, I'm trying to, because I was working here at Ace Host, and I built the whole network out by what I learned from that switch that I got. So I'm stepping through the whole story there. It's like I learned about the whole switch, what have you, and I was like, all right, great, cool, now awesome, I have this switch, I got it up and working, and then I went down a whole knowledge path there. I was like, all right, well, I just have a switch now. A 40 gigabit switch does nothing. Like, it just runs my little lab environment. So the next step was like, okay, I want to build a data center. And then all of a sudden, this VP just calls me out of nowhere, hey, man, we could use your help. We're building a data center. I'm like, well, I just got done learning something. That's weird. So I did that, and I said, yeah. And like I contemplated around forever because I was working at Red Hat. Like, that was the company. Like, that was the GOAT in the Linux world. Like, you made it. You're there. You're done. Now just climb the corporate ladder. And I was like, nah, I want to go do that. I want to go build a data center. Like, and I took the position, and I came over here. I met with the whole C-suite, laid everything out to them, the whole proposal, the cost, what have you. And they're like, oh, hey, we've got junior guys too. You got to teach because they don't know anything. I'm like, all right, cool. So fast forward here a little bit, rebuilt the whole data center out, teach these guys how to use Linux and deploy and do that kind of stuff.
So you're teaching these guys, and you just learned it.
Yes.
Nice.
So
that's how tech works.
Yes. But I mean, when I was in the military, it was a concept: show one, do one, teach one. So senior guys showed you how to do something, you do one, and in the process of doing it, you learn extra things, and then you go and teach it and then build upon the knowledge that you were given.
Oh yeah. So
but anyway, let me get back on track here. So I wanted to build a public cloud at Ace Host, but the problem is that like we didn't have any funding to hire people, right? So we needed to build revenue out. Well, this is like when everybody's going over to AWS and all the other cloud providers, so it was like really difficult. And plus, too, I barely understood what a cloud was and needed to learn it. Like, do we run it on OpenStack? Well, not really. OpenStack's kind of dying, dude. Like, the only people that use OpenStack are big telcos. So I was like, all right, cool. So we'll know all these people, what have you. And then there was this one common technology that all the other cloud providers, GCP, Azure, like, they all use Kubernetes. I didn't know anything about Kubernetes. I was like, what is this witchcraft over here? And when I looked at it, I was like, all right, I got to go back to Red Hat because I got to learn OpenShift. I need to learn all this stuff. I need to get back into Ceph and get back into this, software-defined stuff because that's what's going to build the revenue to bring the cloud up. So I went back to Red Hat, started working there, and working in support organization for all the helping out various customers, what have you. And then on the side, I was getting all the certifications that I needed to learn the technology to become a certified architect. Because I think that when you become an architect, it's important to adhere to the standards of the technology that you're implementing. So what I ended up doing, I ended up going to Red Hat, going back to Red Hat, getting my certified architect, what have you. And then I was moving down a path in that organization that I just didn't want to go down. So I just decided to depart. But to go back to, I met Charlton, who's the ex-president or I don't know if he's the current president. Oh, no, Matt's the current president. But Charlton was the former president of Tampa Devs. He's now a trustee, which will probably change later on. But he and I met at a meetup where they were talking about how do you get a job in tech? Because it's I went over there and just kind of sat in because I didn't have anything better else to do that day. And then I saw Charlton over there. I saw all the nerds over there in the corner just slapping away through keyboards. I'm like, oh, what are y'all doing? Let's over here. And then they're talking about the Tampa Devs infrastructure. And I was like, oh, I got a data center. And they're like, really? So we started talking about the different cloud providers, and of course Charlton and I just nerded out, because he and I kind of have a lot of common interests in the technology world. He's more so of the application side. He leans more towards that side, but has discipline in the infrastructure. Whereas I have more on the infrastructure side, and I lean a little bit. He and I come to meet right there in that sweet spot where it's the application guy knows just as much about the infrastructure. Anyway, he and I met, and then I was just like, hey, I got this whole cloud right here. But this is still when I'm working at Ace Host, so I'm backtracking a little bit here. So before I went back to Red Hat, I was because I had a whole rack of just a development environment. I was just I don't want to give that up. So how do but they're not going to let me keep it if I don't work here anymore. So I remember going to Tampa Devs environment, Tampa Devs meetups, just to meet other tech people to try to build some sort of product to be able to generate the revenue to justify additional salaries. Because that's kind of what happens when you work at the principal level. You got to be able to have those conversations with the C-suite. So I met when I had that whole rack. I was like, how do I do this? Well, when going through the business world, I remember reading about 502(c) organizations and what you can do there. So I was like, hey, Ace Host, you guys need marketing and free advertisements, right? Hey, Tampa Devs, you guys would love some data center stuff, right? Yes. Okay. We marry the two, and then now Ace Host gets free marketing. I get to keep my rack and maintain it, and then Tampa Devs gets, they basically get the free rack and IP space. So that synergy in place. Cool. So now the next part is I go to when I talked to Charlton came up to me one day, and he and I started talking about doing a public cloud. And initially, the very, very first one was it was all CentOS running what's called a libvirt, which is the virtualization engine that runs on Linux. everybody uses either libvirt or Zen to run their virtualization workloads. I mean, I know there's Hyper-V. No thanks. No offense. It's not the world in which I live in. It has no use case. When I look at, like, when Charlton came to me about that, he's like, okay, let's build a cloud out. So I was like, all right, cool. So we'll have here. So I built this whole clustered out environment with a shared storage, a Ceph storage, not running Proxmox, just bare libvirt. Set up all the clustering, did all the live migration aspect of, like, which makes me laugh sometimes when I see VMware charging for live migration. I was like, dude, you could do that for free on Linux. It's easy. An easy thing to teach, an easy thing to set up and implement. It's just a little bit of a learning curve, and then you're good. But then I set up the Ceph storage on the back end, deployed some virtual machines out, and then put some weird names on there, like was it with like weird names like eagerbeaver.on.tampa or just to kind of make
it has to be fun.
Yeah. So we did that, and then basically he's like, hey, we could use a cloud environment for the hackathon that we have coming up that I was a panel judge for. Nobody used it.
Oh no. All that
right. Well, the thing was that nobody used it not because it was like nobody wanted to use it, is because it was a technology, like, virtual machines are for infrastructure.
Yeah.
Not developers. You can try to marry the two, but it becomes like a duct tape, like popsicle stick kind of house. And you get people kind of more angry at the workflow instead of like the technology part. So then I was like, all right, cool. OpenStack is not going to work. Like, we just did bare libvirt, which is not that complex, with Ceph storage, and then utilizing this thing called RBD to do all the shared RAID block device to do all the migration between each host. And nobody was like, just used it. They're like, no, this is too much. We don't need to do all this. We'll just run a Docker container locally on our MacBooks and then present it that way. I was like, oh, okay. So that's an insight I didn't know about. And then I was like, all right, cool. So then Kubernetes is, that's the route we got to go. So I pulled the whole cloud down and when I reached back out to Charlotte, I was like, yeah, OpenStack and that type of VMware, like VM virtual machine way of doing things is not going to work. We're going to spend more time teaching people how to use the cloud than them actually using the cloud. And that's kind of where that was the delimiter there for me. So then I found the Kubernetes and how to orchestrate all of that out, and then have Kubernetes ingest the Ceph storage, which is actually a really cool project upstream called Rook Ceph. And then went back and deployed it all out, and then ran into some performance issues because we're all on spinning Rust. I mean, we were getting 70 IOPS. Like, I get one user on, great. Another user on, just blow up.
That's not good for cloud.
Yeah, but that's the whole story. So I know that was really long. I apologize, but that's how the cloud came to be.
So from a hackathon, and then now the initiative you're going for schools. Is that what I read in the releases, the press releases? That this is that you're going to put something together to help out local schools who could, and the students there who couldn't otherwise get access to cloud infrastructure.
Right. So one problem a lot of like people have when it comes to like that I've noticed, at least, and I could be wrong. I mean, your mileage may vary here, but the one problem that I always come around when it comes to deploying something is that at the small scale of like, I could just do this on my laptop. Yeah, works all day. You're fine. But the experience that nobody gets to have is running things at scale, because that gate is very much kept. And there is and I've noticed is that's where developers and operators and everybody just kind of quits, is right at that line. where it's like, I really want to see if this does anything. Does this make any kind of money? Can we do that without and the developers just want to deploy that. That's what they want to do. They just want to deploy the code. They just want to see if it works. If it doesn't, we tear it down and we find something else new. And the problem is that line of pushing it out to scale and seeing if it works versus running it on my laptop is so hard to cross. Because you have you have financial dependencies, you have personnel expenditure pieces, you have utility stuff, you have all this other stuff, and that's and with the school part, we remove all of those barriers. Where it's okay, you want to run things at scale? Okay, cool. Here's your API. Here's your namespace. Here's your Kubernetes resources. Let's do it and see what happens. The only thing that I ask for in return is you come and do a talk about it. And let's hear about all the stuff you failed at. Let's hear about all the stuff you were good at. And let's all laugh about it. Because that's what makes IT fun. Not are you right or wrong, but where did you mess up? Let me hear about that. So is that, and then the school part is that's, long term, yeah, sure. When it really, really grows, but really the root of it is we get people from the schools to come out and use it and then go back to their schools and then showcase it without having to use the school to showcase their work.
Because there's a lot of red tape when you go through. I was just part of, we're part of a group that did, that taught some kids coding down in North Carolina. Or up in North Carolina, depending on where you are in the U.S. And the red tape that they had to jump through to just get access to have a classroom to teach kids was crazy. Yeah. And then they started, and then all of a sudden they're like, "Oh, but we can't give you internet access." And they're like, "We're in this; it's already here."
Right.
No, we had to jump through a bunch more hoops, and it was. It's unbelievable. They're we're just giving free education to kids that already go to the school, and one of the students was a child of one of the parents doing the free stuff. And it was crazy the hoops. And so I get it. If you can make it easy for somebody or for a teacher who wants to or a parent or a child of a school to kind of do something like this for their kids, it's going to be huge.
Right. And so we do kind of put some technical barriers in place. Because this cluster now, thanks to xByte, the donation, you called me up, hey, you want some free stuff? Yeah, what do you got?
All right, so let's take a second and go into that. So you had talked about 70 IOPS, 70 IOPS originally.
Yeah.
So you have the new stuff in place. And I say new, it's new to you guys. For those who are listening or curious about the actual hardware architecture, they're running R930s. Justin was a big fan of 930s, and we had some, so we're like, all right, yeah, we'll help you out with that. But have you tested the IOPS now? And you're not running spinning disks anymore.
Yeah, I know.
These are I don't know if we gave you NVMe or just SSDs.
So you just gave us SSDs, like SATA SSDs, which are still only going to limit us to 6 gigabit per second, which is totally fine. 6 gigabit per second is still very fast. I hear people say hey, it's just 6 gigabit. Bro, it's 6 billion bits per second we're talking about right now. And we were getting 70 IOPS, and I was maybe getting maybe a couple hundred kilobytes, if I was lucky, and put output throughput. Now we're exceeding 2 to 5 gigabit per second across the cluster. No, gigabyte per second across the cluster. And I'm seeing, anywhere from I think around 1,100 IOPS sometimes I'm seeing. It also depends on what kind of workloads we're running. I haven't done any real like hardcore benchmarking because right now I'm focused on side of the automation aspect of it. Like, hey, I need to make this as easy as possible to deploy, because if I put any hurdle around it, then it's just, where we got to kind of figure things out with the amount of time that we have to invest into it. It's going to kind of start to die. So I need to make it as cool and as easy to deploy as possible. So that's why I'm focused on the automation part, which is really hard. But yeah,
let's dive into that first. Let's dive into that for a second, because I think people watching, listening to this are curious about kind of how you made this happen. So we talked about the actual technology, the servers piece of it. What are the software applications that you're running to make all this happen? Are you still running? Is it just did you add Proxmox, or are you still running no Proxmox, just OpenCeph?
So I'll kind of run through it.
Just Ceph, sorry, just Ceph.
Yeah. So Ceph in and of itself upstream it was made by a guy named Sagewile, and I'll let people kind of go down that route. It's a great technology. I would almost compare it to ZFS. That's not, but the problem like with ZFS or ZFS is what it's called, the zettabyte file system. It's wrapped up in so much legal jargon. Most open source companies won't touch it because it's just so blocked into. But anyway, with Ceph, it was invented by a guy named Sagewile who did his whole dissertation on it. It's a really good read if you can kind of understand the math behind it. It's just basically what we do is that if I take a 1 gigabyte file in very simple terms, I'm going to take a 1 gigabyte file, I'm going to break it up into small 4 kilobyte chunks, and then I'm going to carpet bomb it throughout the cluster. Okay, so, and then that allows us to do things more concurrently. So the storage system is Ceph storage. Not Red Hat, not IBM, just pure upstream Ceph storage. The operating system underneath it is CentOS, which basically has libvirt set up and allowing some migrations between each host. And then on top of that, we run what's called Open Kubernetes distribution, which is the free version of upstream OpenShift. So I don't want to be in any vendor space with this project, and mainly because with the age of AI right now, vendors are kind of gatekeepy about their technology stack, which is understandable. So I'd rather just nope out of the whole vendor space and just use pure open source. If we can't pull it from open source, then I don't want to be involved with it because I don't want to go down any legal jargon. I want to stay as far away from the red tape as possible and just focus on the technology side.
Now, what do you have for automation? You mentioned automation.
So what we're using right now for the automation side is Ansible, and we don't use Terraform right now, and I get the argument that some people have about Terraform and Ansible. I would almost argue that I think it's better if you know how to get back to the state that which you were in. Then I don't really see why we need to keep track of the current state, more or less, right? But there's different workflows for different things. This cloud right now is being designed around the concept of largely being transient, where it's like, hey, if a vendor's like, hey, we don't really want to support this project anymore, you guys can get out of here. So now I got to go find another vendor to put the whole cloud infrastructure in. And if we use Ansible and just kind of keep things kind of transient, then I can use Ansible using GitHub Actions to go ahead and deploy everything in a very linear state and a multi-stage. Because with the cloud infrastructure, it is very multi-stage, where it's like, okay, before I can deploy the virtual machines, I got to have shared storage up. Before I can do the shared storage up, the network has to be up. Before the network can be up, we have to have all the links in place. So you have to step through it, and a lot of it has to do with the fact that I know Ansible. So
I'll tell you, a lot of decisions are made because the architect knows software or hardware, and that's as good of a reason as any to do something.
So, and it's, if Terraform is better for this, I'm open for it. You know what I mean? But It's right now I know Ansible. I know Ansible like I know Bash. It's just I know it really well. I know how to use it really well. It's got, even though I'm not really a fan of Python underneath it, it's just like, who cares? Like, can we get it up and working to let developers utilize it? And then can we benchmark at each state? Like, can we make that whole deployment process more efficient? And
so if a developer wants to, so it gets up and running.
Mm-hmm.
You said you want to make it easy for developers. What do they have to do to get a Kubernetes container up and running for their project?
So right now it's the only dependency that I'm kind of, mind you, this is somewhat transient right now, where it's like I'm still in talks with other members of the Cloud Council right now. And it's just like, hey, as a developer who sees this project, all you have to do is just come out to a meetup. Or give a talk and say, hey, I need cloud resources. Can I use the Tampa Devs cloud to showcase this talk I want to talk about? Yeah, sure, absolutely. Largely right now, the only reason why we do that is potential for abuse. Because if I put a sign-up portal right here, then some guy that's not even a part of Tampa Devs, or some girl or guy or whoever is not even a part of Tampa Devs, can just sign up and start using it without contributing anything back to Tampa Devs. Because that's how they do it right now. That could change later on, but largely it's like, hey, there needs to be some sort of synergy in place where it's like Tampa Devs is giving you a resource, now give something back in the form of a talk. You meet up.
That's fair.
Yeah. I'm not asking for financial contributions. I'm just asking for participation, which I think is a very low bar, to give someone free cloud resources. So, and it helps everyone involved, because now, you don't become that IT nerd that's sitting in the basement that's just all weird and just like, oh, I'm playing World of Warcraft right now. You come out and you meet other people and you collaborate, and then you find better opportunities. Like, hey, I really liked your Java app, or your TypeScript app, or your insert language here app. We actually have this problem right now within our organization that I think that you might be able to help us solve. And then that allows to push people forward in other ways.
So for a developer, they'll be able to then integrate this into like their CI/CD pipeline, mm-hmm. and so they want to do up like their dev environment. They mm-hmm. They spin it up, and they'll be able to spin up any environment.
So, to give a better example, we have this program at the Tampa Devs called the mentorship program. Okay, so for anyone that wants to come and be a mentor, that's great, awesome. We highly encourage you to come in, sign up for it. We also have a recruiting program, but the whole point is that if you're a mentor right now and you're trying to teach somebody something, right? Either you're going to have to accrue the cost as a mentor to teach someone something, so you're going to get something taken from you and not getting back anything in return. Or the mentee is going to have to accrue a cost to do that, right? Whether it be in the form of power, utilizing their own power, utilizing their own, or insert some other form of red tape here. And I'm trying to remove that barrier where it's like, hey, let's just focus on the tech side. You're the mentor, you're trying to teach this guy about something tech related without accruing a cost. And the mentee's like, I just want to learn it. So let's just foster that as an organization and then allow that to happen without all of the other stuff involved, more or less.
Now, do you have to allocate the resources that they get, or once they have access, will they be able to spin up any environments they need?
So initially by default, there's a limit so within Kubernetes you have the project namespace, or the project space, or the namespace, or the tenant space, whatever you want to call it, and then you can limit the namespace to a certain utilization size. You can limit storage allocation to a certain size. You can limit every resource of Kubernetes to a certain size. By default, and we're still testing these limits, but right now, for example, in Kubernetes, we have this thing called millicores. So you get 500 millicores. So right now, it's you get 500 millicores, and then you get a gig of RAM right now. And as we have people test more and more, that limit will change. But if someone needs more resources than what they're given, because the goal is to, I'm not trying to run your business on this platform, okay?
Yeah.
So it's, if you want to do that, then like, we can sit down and have those talks and allocate those resources to help support it if we have the ability to do so. But that's not really the goal right now. The goal is to build Tampa Devs up and get that participation in there without all the corporate stuff. But if they need more resources, like they deploy a project like, hey, we need more resources to run things because we want to try it at scale now. We worked out all the bugs. Okay, great. I'll give you more resources. We have those talks, or you put those requests in, or we go to a meetup and like, hey, man, I really like this platform, but the limits you have on me right now are just not working, and I really like to do that. Okay, great. I'll give you those limits, but you got to do a talk about it.
So then, so you create this container, and then are they responsible for installing anything they need to there, or like if they happen to need a Windows OS, is that something that you have to deploy in the environment?
So within Kubernetes side of it, you can run virtual machines inside of a project called KubeVirt, which basically takes the libvirt virtualization engine and then puts it into what's called a container, and then we put it inside of the container all the resources that we need inside of what's called a pod. Inside of that pod, we put all the resource constraints on that with inside of the namespace. So it's kind of like Russian dolling it, more or less. But what happens here is when they need to install, what they'll do is that they're like, hey, I want to run a PHP app, or I want to run a JavaScript app, what have you. They'll take the container image for that language, pull it down, and then or they'll have, like, let's say, a GitHub project with all of their code in it. And then inside that GitHub project, we have a Docker file. That Docker file, we then go to the project and says, hey, here's my GitHub link, pull it down. And then it pulls the code down and deploys the base pod out, or base container out. And then they can build upon that. Or automate that whole bootstrap process. The virtual machine side, it's in the works to be also supported. Like also supported from the perspective of like, hey, we can provide that.
Right now it's more of the pods for applications. Then you have to have a separate pod for database if your app needs a database?
So you can put everything into a pod. Like, so let's say you have a LAMP stack. Within that pod, you have your Apache, you have MySQL, you have your Apache, MySQL, and PHP all in one pod. And that's your whole stack there. And then that's what we call it the deployment. And then we make n number of replicas for that deployment. So as the things come in and we load balance across the pods, because really what Kubernetes side is like, hey, we need to scale out east-west. As the load comes in, I don't need to be really fast. I just need to be able to handle a lot at once. All right? I need to be able to handle a lot of things at once, because that's kind of the difference between, like, being concurrent versus parallel, which is a whole philosophy that I don't want to go into right now. When really it's just about dealing with concurrency, and concurrency is really, really hard because like if one resource is off, then it throws off the whole thing. So when they come in and they request the resources out, they request the pod, then we deploy out the pods out to handle the incoming load. So we scale it outwards. And then if we need to load balance more efficiently, then we have other projects like MetalLB, which will allow us to do, other than HTTP, besides web traffic. So there we can go in any different direction from the application world.
So is this ready right now? So if there are developers listening to this and they want to be part of the Tampa Devs public cloud project, they can just reach out to you.
So
or reach out to Tampa Devs. Or is it launching in a? I know you and I had talked before about a couple months, really for launch of this.
So right now, there's another guy by the name of Brian. He's kind of like my, and then another friend of mine who's over actually in Denmark who's helping me with this. Right now we're developing all the bugs. We're setting up not developing all the bugs, but we're working all of the bugs out. Because the worst thing that you want to do is come to a community project and nothing works. It's like there's all kinds of problems here. I don't have the time for this. Let me, so it's just, we're working out all of the bugs, I'm going over all the architectural designs of it. I'm measuring packet loss. I'm looking at throughput on that side. And then I'm also doing all of the automation scripts where it's like, okay, if we hit some limit, for example, how do I just go ahead and deploy more without having to go to the data center? Having to have somebody wait a day for that to happen. Like, I'm trying to set it up where I call it the data center grunt work, where it's like, okay, I need to go into the data center, deploy a rack and what have you. And it's just, I'm trying to limit that as much as possible because we can't allow everyone to just come into the data center. There's all kinds of certifications and so I'm trying to limit, like, hey, we got to go to the data center as much as possible. And I mean, if that goes down that route there.
Yeah. So the plan is right now, late summerish, July, August time period.
Yeah.
More of a public launch of this.
So the week of the 9th, now take this number with a grain of salt, this week with a very grain of salt, because everyone who's working on this project right now is kind of working on a volunteer basis, except for me right now. Everyone else is kind of donating their time. So right now the agreed upon time is the week of the 19th or week 34. I think it's the right week number, but
and then August 19th?
Yeah, August 19th.
Okay.
So that's the tentative date right now.
Okay.
When we're actually going to pull together like a whole group of people, that's week 34. We're going to pull together like the people who all contributed to it, reveal it, celebrate their work. Like, hey, Brian over here did this. This guy did this. It's like I know I bootstrapped the whole cloud, but I want it to be about everyone else. Because I'm just trying to remind people, like, hey, this stuff is actually fun. Like the data center and building out applications, and I mean, even on the work that you guys do at xByte Cloud with all the Cold Fusion stuff. Yeah, it's not great. It's not the most sexy technology, but people enjoy it, and you guys are there supporting it. And that's
what's crazy. One little quick sign up on Cold Fusion is people like, oh, it's old and everything. I'm like, I mean, all these languages are old. Python's actually, I think, older than Cold Fusion. But it's used by so many people. I mean, and we had somebody signing up for after the Broadcom acquisition of VMware, signing up for a VMware webinar. There's too many people because everyone wanted to know about licensing and stuff, so it crashed. And the error was a Cold Fusion error. It's like, really, VMware's running it. Like, it's crazy. All these people, like, it's kind of like behind the scenes. You don't realize. You talk about. I think you're talking about Zen being so popular out there, and not realizing that all these companies actually use it. So it's very exciting for August 19th out there, and I think it'd be awesome to even have you do a presentation like you talked about having devs do, where you go through and you present, hey, here's everything we learned. In case anyone else, anyone else wants to do this and kind of all the lessons you learned at I was part of another podcast, and we just interviewed people who did a Proxmox plus Ceph cluster. Their AWS bill was getting crazy, so they made a decision to try and bring some stuff back in house. And there's lots of lessons learned about AWS and Ceph, or not AWS, but Proxmox and Ceph.
Right.
So it's interesting to talk to them about that as well. And even they're talking about some even connections between the servers. They've done some fiber connectivity and realized that was difficult because of any little bends or anything will have issues. Yeah, so they're rethinking their connectivity.
Another thing to add here as well is like, I want to make one point here clear too. Like the point of this whole cloud here is to have fun. It's not here to run a business. It's not here to, oh, we gotta adhere to some corporate. You gotta adhere to some corporate thing here, right? I'm just like, I'm not here to do that. If you want to run a factorial game server on it, like let's hold a little LAN party together where we're all connecting to the same cloud instance in the Tampa Devs cloud. We can do that. If you want to run, like, hey, I want to see how much money I could actually make. Like running little miners here or there in this little namespace, just to kind of see it and showcase it, and then do a talk about it to see if it's realistic or not. That's the idea. I'm not trying to gatekeep access to this. I'm only trying to protect it and keep it alive. And then I've been working in this world for about 10 years now when it comes to the data center world. So, and I've operated at, I've operated at, the level, what's called the ARIN level is what I call it, the American Registry of Internet Numbers. You want to talk about bureaucracy? Go through that process. And I mean, I had to learn how to speak like a lawyer just to go through the whole IPv4 acquisition, like IPv4 space and IPv6 space. And anyway, like I see those traffic patterns, what they look like. I mean, the data center network side, it's not nice. The traffic is not nice. You're going to be dealing with DDoS attacks. You're going to be dealing with, people, what's called SYN floods. You're going to be dealing with all kinds of nefarious things, but you're also going to be dealing with good traffic. And how do you separate the two? And how do you load balance it? How do we keep everything online? It's an endless number of lessons that I've had to learn in the data center world. Like my first week as a principal network engineer, I show up like, hey guys, I'm here to like be a big boy network guy now. And it's like, oh really? 7 terabit DDoS attack. First week. And I didn't have a team. I didn't have a senior engineer to reach out to. Everybody looked at me like, what do we do? I don't know. Like,
so what do you do?
I reached out to one of the providers. His name was one of our providers at the data center at the time. I go to this guy, shake his hand every time because he was the only guy that I could reach out to and collaborate with, and we were one of his customers. I'm like, hey man, we're not running Cisco, we're not running this, we're running the Linux version of the network operating system side. We're getting DDoS right now. What do we do? And he's like, well, and then we kind of stepped through, looked at the traffic patterns together, and then we ended up adding what's called a BGP null route. So we propagate upstream through the BGP advertisements to our upstream providers that we're peered with, and we say, hey, put a black hole route on this endpoint. So it then propagates out to the rest of the internet and effectively shuts down the attack. Because who you're trying to get to just basically goes into a black hole, more or less. And then after I learned that lesson, I was like, okay, we're going to set some stuff up now. And I ended up using some open source technology at the time to sit on each one of the switches and kind of monitor that data plane traffic. Now, if you hit a certain level, like if I start to see like a certain level of SYN packets that are coming in that it looks like a certain traffic pattern, then what will end up happening is we'll dynamically add what's called a BGP community called 666, which we then advertise upstream, which to say, hey, null route this endpoint. So it shuts it down immediately before it even gets a chance to get those higher levels.
Interesting.
It's a little automation trick you can do inside of some open source stuff. I don't want to say which ones because everyone does. One thing that I'm really kind of afraid of is like violating some sort of license.
Or exposing architecture, and now all of a sudden they're like, oh, okay.
Yeah.
Now I know how to get into your system because there's a 0 day on this piece of something, of your architecture.
And they've got security stuff in place too, and I can't go too much into what things are set up, what have you. But I can say that I've adhered to all. When I was designing things, I was adhering to the appropriate RFCs for BGP and the appropriate RFCs for the architecture, like how the class topology was set up, the spine leaf. Go ahead.
I was going to say, so you had talked about a second ago, everyone on the team being kind of volunteering and donating time when they have it. and we had teased in the very beginning that you left a company to kind of pursue this passion project of yours, and we can tell, or like I can tell throughout this interview today that of your passion about all of this. What drove you to? We're not gonna bash any companies here, but what drove you to leave your other job and kind of pursue this? Because I know there's a lot of people out there who are in jobs and they're like, okay, do I stay here or do I pursue something that's more of a passion of mine?
So
what? Yeah, go ahead with that.
So this is kind of a question most people would probably think this is probably an answer that most people would probably think I'm crazy for, but I was 17 years old and volunteered to go to Afghanistan when I was getting out of my house. So, I mean, it's like I've done crazy stuff my whole life. Crazy to me is fun. Like, you're doing crazy, riskful stuff is fun. And the best teacher is experience. It's not sitting at a job where you're just going to be like, hey, well, maybe if I find the right person and do this and what have you, maybe we'll get in it. No, you just got to get up and go after it. And if you fail at it, at least you tried. So what made me go this route was just like the data center world for me is like a love and hate kind of relationship, because it's the hardest world to operate in, but it is the most rewarding when it comes to learning the technology. You can only do workflow once. You set the workflow up and then you make tiny adjustments to it, right? Which is what big corporate worlds are kind of geared to. Once they get the technology in place that they're selling, that technology it's automated now. We're just focused on refining the workflow process. And what I learned at the bigger corporations is that they're more so concerned about the workflow and the people side now, which for me it's great. I mean, there are people out there who have kids, they have a whole family, and they just want to go to a job, do a very defined task, and then go home and celebrate with their kids. And that's fine. I'm not bashing that at all. Like, that's wonderful. That's what works for you, and that keeps you getting out of bed every day, being in service to something that's not yourself. Great. I encourage it. But for me, I set it all up in the beginning. When I went into Red Hat, when I went back to Red Hat, I was like, all right, I'm going back to learn the technology. Because when I initially left Red Hat, I was working on the networking team, and I met some of these smartest engineers, and it was so fun coming into work. Like, we worked on one project on the networking side where there was an organization that was getting UDP packets out of order, which I was like, yeah, it's UDP. It's not reliable. It's the design of it. And they're like, no, we need that to work. And I'm like, it's not how it was designed. And then I kind of, instead of just jumping to conclusions, a senior engineer I had at the time reached me and goes, no, Justin, stop it. We're going to go over here. We're going to talk to them. And I actually learned a lot on this one project where it was like, hey, what's going on? So with TCP, we have the concept of sequence numbers so that way we're like, okay, as we're going down the stream, we can kind of see where we're at and what data we've lost and retransmit the missing data. UDP, we don't have that. But when you do that within TCP, you accrue a form of latency with all of that checking, right? Which some developers are trying to shave off. So what a nifty little trick that these developers are doing is that they push that up in that sequence number, like that data reliability, they push that up into the application layer. And they put those sequence numbers in the application. So we get and the UDP packet is small. It's only 8 bytes. It's really tiny in comparison to TCP. So I was like, okay, I didn't know you could do that, but sure. And what ended up happening is they were transmitting data from satellites, and which we all know is like the worst. When it comes to network traffic, it's like maybe you do it, maybe you don't, maybe you lose it, what have you. But they were transmitting it, and what was happening was that the packets were arriving in order all the way down their network infrastructure, and then they would hit a switch, and then they'd hit the switch, and then they'd go down with the bond, and then arrive out of order on the hypervisor. And I'm like, you guys, what? And when I'd say we had like 10 engineers on one call trying to troubleshoot this, we were diving into network buffers. Is the buffers too big? Or do we need to set C states? Do we need to go here? We need to look at the route tables. Are the bridge configurations off for this? Because we're diving into uncharted territory right now. Because like none of us need to do this. And come to find out, it was a bad cable. And I figured it out because I had in my lap. Go ahead.
All that for a bad cable?
Yeah. So it's one of those things like where basically what we ended up figuring out was, so the networking team at the time locked the speed of what's called the bond or the aggregate, or in Cisco they call it an ether channel, where they basically take the combined capacity of 2 links or 3 links or 4 links, and then they put it into one logical channel to transmit up and down. Well, one of those cables was bad. I don't know what was wrong with the cable, but what was happening was that the bond was able to figure that out, and then it would buffer all of that traffic up on the switch, which would basically like take the packets and let's put it into this big jar as they come in, and then we then read from that buffer, but there's no guarantee that they're going to be in the same order in which they arrived. So first in, first out, first in, first out, first in, first out, which is typically the scheduling algorithm that most switches use. But they would be arriving into the switch. The bad cable, the cable would be bad. So it would push it to the other leg. So now we jumble all these packets together down one stream, down one leg, and then it arrives on the hypervisor. And I was able to figure it out. And when I was able to reproduce it, I almost fell out of my chair. Like I was in a meeting and I was like, I got it. I fell back and that was actually a contract that Red Hat was in competition for VMware. Like it was like, yeah, it was a really cool, like there was a really cool event where us fixing this problem was the difference between them going to Red Hat virtualization versus VMware.
Oh, wow.
Yeah. So I didn't really care about that part. I was like, I just figured out.
You like to fix things.
Really,
go ahead. Yeah, I get your passion with all this, and you love to kind of get your hands in there and figure stuff out. So that was your first trip with Red Hat, and you came back, and then the new job. I can see your passion with the first group. Your second group, was it the same passion? Is that kind of what led you didn't have that same passion?
Yeah. So to me it's just the experience. So like I'm out, and the money will come. Money is easy to make. You can go to any job, anywhere, any place. You can go dig ditches and make money. You can go to McDonald's and make money. Money is easy to make. The hard part is the amount. Now but if you say like, oh, I want to make $1 bazillion a year. Well, why do you want to make $1 bazillion a year? Well, because I just want to. Okay, but why though? Is it worth your mental capacity right there? And so I've never chased money. I always chase experience. And the benefit of chasing experience is that money comes with it. Because as you have more experience, you have more to sell, and you become more valuable to the person because of your experience. So I've always chased experience. And sometimes when I left Red Hat and then I came to this data center job, like nothing was set up. But I saw the experience that I can mine from this position. And that's why I went over to Ace Host. But then I saw that I needed to go back to the academic side of it. So that's why I went back to Red Hat. And then when I saw like I was going down a direction I didn't want to go within support services, I wanted to go back over to the operational side, being being what I call the data center gangster. which I didn't coin that term, by the way, for all of my IT friends out there. It is.
We can give you credit.
No, actually, I'll send you the video later on, which that stems from. But it's called if you search on YouTube, it's called IT Guy versus Web Dude.
Okay.
So it's a funny thing. But anyway, it's I came back here to do this because there's a huge amount of experience that I can gain and mine and own, and then it's going to benefit a community of people. So I don't really talk about this much, but I mean, this technology saved my life, and I have to keep it going. I have to give some sort of thing back because I've been taking for so long.
So can we go into how it saved your life? This could be an interesting story.
So I was deployed to. So when I was 17, I went to the Navy. I was kind of one of those kids where it was just like I was a wild child, and a lot of the reason why I was a wild child because I was just curious about everything. I just wanted to get my hands into everything and figure things out and kind of experience everything. And I got an opportunity to leave my house and go to the military and go off in Afghanistan. It's like, oh yeah, I want to go fight and blah blah. You know, I want to go to war. Yeah. So it's just I went and joined the Navy. And I became what's called a hospital corpsman, and then I went down, deployed with the Marine battalions to Afghanistan. I was there for 8 months, and then came back and was kind of like, feeling a lot of things like I was going through some feelings of shame and not really knowing where to go, and I was working 6 days a week and was drinking a little bit, and it's just like was feeling really, really lost. And I met a guy who showed me Linux and showed me this whole world. And I've just I stopped drinking because the booze, it affects my ability to remember things and learn things. I stopped, it made me go to the gym because if I work out more, now I improve the circulation. So I get more blood to my brain now so I can learn better, so I can implement more cool things. And actually build more and more and more. It made me start taking care of myself more because when I stopped taking care of myself, it became harder to do this job. So now when I say it saved my life, it gave me something to be in service to. And I think that as guys, I don't want to go down this whole philosophical route, but as guys, I think whenever I looked at older people who are older guys that are really happy, they're always hard charging, they're always a leader, what have you, it's because they're in service to something. And I think that's really important because if you're not in service to something, then what are you doing? And part of the reason why I'm doing a lot of this is because when I look at the current generation right now, it's like, I mean, the boomer, like the baby boomer generation kind of came in and closed the door on us with buying a house and what have you and all that kind of stuff, right? And then it became kind of harder to move up on millennials and Gen X. The Gen Z kids, I mean, they have TikTok, and which is like, oh my God. I think that the people to look up to aspire to, I'm not trying to say that I'm trying to be that guy, but if I can build the venue for that guy to come out and be that example and take all the stuff that he doesn't want to deal with, he or she can come out and be that example for, then absolutely, let's do it. I think that's when I say it saved my life. It saved me from destroying myself, so to speak.
Wow. So all of that, and you were at Red Hat, and you're like, okay, I'm not going the direction I want. I'm passionate about this other thing. I need to give it back. I need to be in service. So you found a way for you to kind of to do that.
Right.
That's awesome. I think a lot of people. I mean, I know you didn't want to be that kind of role model for people, or you're trying to build a world where other people can step up. But I think that in itself is a role model for people to say, hey, you know what? Chase that passion, get that experience, and as you said, the money will come out of it. I mean, you left what would considered a cushy Red Hat job maybe to do the data center build out, and then you go back and and you're like, yeah, you know what? I'm just passionate other places, and so you're kind of a learner.
Yeah.
You love to get out there and get your hands dirty, so it's good to. But I'm sure there's a lot of people just like that who will be inspired by this to say, hey, you know what? I'm going to go chase my passion. I'm going to go learn because you know what? Money will follow. You make yourself more valuable. It may be a second where you're not making the money, but it'll come, and it's better than just sitting around and hoping. And especially in this AI world, if you're just going to sit back and not learning, your job will be gone.
So, and I think that's what's kind of important to remember. It's like, yeah, we have AI around here, sure. But, it's the same kind of argument that we had with calculators. Remember? Calculators come out or it's like, oh, I don't use calculators. Students are going to cheat. They're going to not be good at math. And it's just like, now calculators are everywhere. But what I think is important to understand is the world is going to change, and it's going to change all the time. And you may be wrong or you may be right, but it doesn't matter because, it's so easy to fall into that negative headspace of like, oh, what's the point? Or why this? Or what that? What have you? But it's like the whole thing when I hear my younger brother, in Gen Z right now, which in my opinion, I think every Gen Z kid should at least go get a degree in like mathematics or some core skill set, right? Within like the general education requirements, a liberal arts degree or what have you. You may not need to, but it's not the degree path. Like with college is the greatest example. It's not the degree. It's not the classes you go through. It's the people you meet along that way that'll come in handy later on. Because they'll be working on something over here. They'll be working on this over here. Oh, I can contribute to that over here. Okay, great. Hey, actually, do you want to do this full time? I give you full salary. Absolutely. Awesome. Hey, remember that teacher we were talking about the other day, blah, 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 who gave us these boring lectures? Oh, yeah. It's because what makes those relationships kind of valuable is the adversity that you go through together. That's what builds those relationships up. That's what makes those 20-year best friends.
Or military.
Yeah.
I'm sure you had that with military.
Yeah, we did. I did. And that's what I'm trying to foster here is opportunities for saying, hey, come in here and go through the suck together and then let's build it all out. And then, when we have those VC people, when we have those people that are trying to get us to lower our price down or trying to, while they make hand over fist on us for doing no work, we get to go back and say, no, because I'm running this whole thing you're talking about right now in this Tampa Devs community right here, where you're trying to say that it's not worth anything. In fact, it's worth a lot because here's the whole user base. Here's what it's generating. Here's how it's all doing, what have you. So it helps me put the power back into the developers' hands. Because this industry was not built by sales and marketing people. No offense, but it wasn't built. It was built by it was created by academics, PhDs, and people who sat in the STEM fields. It was then designed and built by engineers and architects, and then maintained and supported by technicians. And I'm just trying to, and with this, and if I can try to help, and if I'm wrong on a lot of this stuff, I'm absolutely willing to have those conversations. Because being right is boring. You don't learn anything. You're right. Yay. But you're wrong about something. You get to meet, you get to learn something. Something about you changes now. And that's the whole thing. Is where I'm just trying to remind people hey, here's this whole infrastructure, and yeah, it's not GitHub, but who cares? Yeah. It's local to Tampa that you can build friendships with down here. So
I like that. I think it's a great positive note to kind of end this on. So Justin, if I know no pressure on the August 19th date, but you kind of set it down in a public setting, and it's now.
Yeah.
We got to write it in pen on our calendars. But maybe pencil. Maybe we'll pencil it in. If people want to kind of learn more about Tampa Devs, how do they find Tampa Devs?
So you can go to the Slack channel, which you can find on the TampaDevs.com website. Where we have, where you can also see all our vendors as well. xByte. If people need hardware and they need data center space out of the Sarasota region, they can reach out to you guys there because you're actually listed on the website as a sponsor. Ace Host, another other sponsor. All of our sponsors are listed there. So if they need other vendor resources, they can go there. But if they wanted to reach out to Tampa Devs exactly, then what they can do is that they can go to the Slack channel. They can go engage with us on LinkedIn. We're on all those social media platforms, what have you. But more importantly, what I think the best way to do it is to probably the best way is that if you have some sort of talk that you want to talk about, then reach out to Tampa Devs United Slack or LinkedIn or one of the social media platforms. And we can, if the communication channels are terrible, we can revamp those. And then they can say, hey, I'd like to do a talk. Nelson Yee, who's one of the other, all of our board members are listed on the Tampa Dev site. Any one of their LinkedIns, you can reach out to them and talk on LinkedIn or Slack.
I know Nelson's a great guy. I talk to him on LinkedIn all the time.
Oh, yeah. I mean, when it comes to like scheduling and doing events, Nelson is your guy. So that's how to do it.
Okay, so TampaDevs.com. And I'll even add a little bit because I first got exposure by joining a meetup, and so even if you don't feel comfortable right now doing a presentation, on the TampaDevs.com site you'll see the links to their meetups or links to their meetup page, and you can go there and see what kind of events are out there. I know you guys do some shared events with other dev communities in the Tampa area. So exciting stuff. So Justin, thank you so much. Any last words for anybody?
No, not really. I'll just say if you come up to a meetup and you see me, just come say hi. Like if you don't, I'll put it this way, I'm not a mind reader. I mean, there's like 10, there's anywhere from 50 people, sometimes 100. The best way if you guys want to talk to me, nerd out about Linux and the cloud world, the data center world, is say, hey, my name's Joe Smith. Nice to meet you. Oh, hey, man, what's up? And we kind of talk about this stuff. I don't claim to be the smartest guy in the room. I don't want to be the smartest guy in the room because that guy learns nothing. So
I like that.
Yeah.
All right, everybody, Justin, thank you for showing up today and joining us. And if you guys want to chat with Justin, find him on LinkedIn. His name's right here, Justin Herron. So it's Ryan Brown from Cloud Expert Unleashed. Thank you, Justin. Cheers, everybody.
Cheers.